Today I'm going to talk about the Chrome DevTools MCP server and what it can do for your AI agent. As mentioned, I'm Michael Hablich and I'm a product manager on the Chrome developer tooling team. So my day job is literally thinking, talking about making debugging and testing on the web for web developers easier. I didn't start as a PM, like I'm already doing that for roughly 20 years or something like that. I work in tech and I have worn almost every hat in this industry. Like I was a developer, I was a tester, I was a project manager, I was a scrum master. I'm also now a guest lecturer at an university. Yes, today I have, I don't know what, this thing is strange. Whatever. Yes, why do I mention that, right? It's not about bragging rights, it's about what I want to tell you is like, it taught me building software is messy. It's never just about writing code, but it's all about testing it, breaking it, fixing it, validating it, and so on, and so on, and so on, and so on. I will remove that thing because it's distracting me with its bells. Yeah, what it taught me, this experience taught me is exactly what I want to talk about today about the AI agents, right? Because they have an ability to see what's actually happening in the browser and why that is just a big problem when you're using AI coding agents like Codex or Claude or Gemini or Cursor and so on and so on. Okay, let's look at a typical software development loop. So this is not representative, but representative enough. See that pink circle there? That's where almost every AI coding agent nowadays operates. They're incredibly comfortable with editing, linting, building, testing, right? Creating tests. They are churning out code as fast as you can possibly see. Essentially, they are hyper-focused on the implementation details. So they're very good with code, right? But look what's outside of the circle. On the left side, you have this nice little design block there. And they rarely design. You're not really that well versed to do design, right? And afterwards, there's this big chunk of review, validation. So is the outcome that the AI coding agent actually created, is this the right thing? Is it actually what I intended to do? Well, long story short, we've built AI coding agents that are very, very good and experts in writing code. But they are blind to the rest of the process of actually shipping the code, right, to the customer, to the user. Because AI coding agents, they lack the sense to interact with the rest of the development loop. Okay, so it's a blind spot, of course. And for us, looking at the web page, it's kind of natural, right? We write code, and then we look in the browser, and then we see, yeah, that button ought to work, but it's not working. So for us, it's quite natural. This feedback loop is natural for us. But for an AI coding agent, this is the exact moment where their capabilities, their ability, completely stops and falls off a cliff because they can't see in the browser. Because up at that point, it was only text for them, they wrote text, they are not visual, and so on. The interesting piece is this blind spot that I mentioned here, this pink circle. This is very visual. This is very tied to the runtime. Because that's in the runtime, that's in the browser where a code is being executed and being rendered. Okay. So, as I mentioned, when we write code and then we verify in the browser. We verify that the button is working, that the animation looks smooth, and so on. And the agents, they can't do that. They are stuck in the IDE or in the terminal, wherever you're using, whatever your poison is. They're also very good with explaining what the code actually should be doing, right? But they're very bad with actually understanding that the code is actually working correctly. So as I mentioned, they are not really very outcome focused. Yeah, and because they have this inability to see, they have this blind spot, they are essentially coding blindfolded, right? Imagine you have a blindfold on and you're coding. Because they can't see the return results in the browser. Okay, so that's of course that's bad, or it sounds bad. I make it sound bad, but it's also bad, trust me. Because that leads to a very specific and very annoying type of back and forth churn that's happening, right? So we have been there. If you have ever, who in here has used already an AI coding agent? Like, okay, roughly half of you. Who is using it on a daily basis? Roughly a quarter? Quarter? Yeah, probably. Okay. Weekly? Should be more than a quarter now. Okay. Very good. Thank you very much. Right. So for the people that already use that, you might know it. You type something in like, fix this bug. And then coding agent comes back, yes, I made changes and it's now fixed. And then you're kind of like, okay, let me check that in the browser. And you open it in the browser and it's kind of like, you know what? I don't think you fixed it, but there's a new error now in the error console. And why is only half the page rendering? What is happening here? And there's also an Angular error there and so on. What are you doing? And you tell it like, hey, no, you didn't fix it. You made it worse. Oh, what? Why? Please give me a screenshot from a page, for example. Please copy the error message into the chat interface, and so on. Right, and that is just frustrating, right? I mean, for me at least, it's frustrating. I don't like to copy and paste stuff in and out, and then it keeps on telling me, yeah, it's fixed now. And practically speaking, every time that happens, it also burning through your token, through your tokens, right? Because every time you return something, more tokens are being processed. So that's bad because tokens are money in the AI world. So what's the solution? Of course, that's what I wanted to talk with you about today. We built a chrome-devtools-mcp model context protocol server. And this is the bridge we were missing. It connects your AI agent directly to a live Chrome browser instance. So what it means, it gives your AI coding agent immediate access to the power of tools you already know, Chrome DevTools. And that changes then everything completely, because instead of you just hoping that the agent's code is correct, you can actually tell it, hey, go into the browser and validate if it's actually working. So now it can actually check if the outcome is correct. Or it can start reproducing the bugs by itself. The interesting piece is now we don't really need to rely on an agent's confidence to tell us, yes, it's fixed, right? But instead, we can rely on the browser reality because it now has access to the browser. And right. So now let's go into the more interesting part, which is about demos. And let me show you a few use cases, how you can use that. Okay, AI demos. I don't think looking at loading spinners and stuff like that is very compelling, so that's why I recorded videos. But feel free to come to me afterwards and we can do stuff here on my machine and try out stuff. Would be super interested in that actually. Right. So with that, let's have a look. Let's see. Just need to. Yes, that works. Let's see if the internet is good enough. Right. What you can see here. So quick introduction for the 40% of people in here who have never used an AI coding agent. This is an AI coding agent. This is Cloud Code as an example. I think it's Cloud Code. Yes, I think so. What is happening here? The prompt is being entered by the user. That's me, for example, or it was one of our DevRel people. I can't recall anymore who I recorded the demo. The search dialog opens. Slowly improve it. App runs on localhost on some URL. I think I talked with Julian today about that use case. There's an example. Like, what happens here? There's the problem. Search dialog opens slowly. Improve it, and the app runs on localhost. Okay, that's the user prompt. What happens is the AI coding agent starts the browser. Right? Here's the browser on the right side. Is this actually recognizable what is happening here? Because I also have the videos in different format. Does this work? It won't work. Right. So what's happening here is you see on the right side the application that I was talking about. This is the DevTools Times, which is just an application that we're using for testing. This is simulating a typical publisher website like Der Standard, Die Presse, Heise, doesn't really matter. Stuff like that. And what's happening here is the page is being opened by the AI coding agent because now it actually can do that. It can drive the browser. And its opening page and triggers, it starts a performance trace, that's this, here it calls a function here. And then it triggers an interaction. Why does it trigger an interaction? We already heard that in the first talk today, because it also wants to measure IMP, of course. You can also do that, right? Yeah, it's doing that, and then it's measuring it. It takes a little bit of time. Right. Yeah, perfect. We return a performance insight, which is the same thing as you would see in the performance panel. If you open the performance panel, take a trace, and you get a performance insight. This here is the same thing that's happening. The AI coding agent gets its performance insights, and that's IMP breakdown that is looking into. It's processing that, and it's like, I found the performance issue. The search dialog fetches the article data every time it opens, and there's no prefetching or caching. This causes a delay while waiting for the network request. Sounds obvious, of course. Yeah, doing that, it's now fixing it with a lot of code changes, and it's verifying that it's actually being faster. So it does again, reload, it does a performance trace again, and it also should give a summary, right? And here's also a summary. That's what Cloud Code, for example, is doing. It's very task-based. It's saying, yeah, now it's faster, which is exactly as intended, right? It reproduces the problem and tries to fix the problem and then validates the fix. Very good. So let's talk a little bit about the technology that's all of that powering this. What exactly is MCP? So technically, MCP stands for Model Context Protocol, and is an open standard that connects any AI agent like Gemini, Claude, Codex, OpenAI, ChatGPT to external tools and data. Generic definitions can be a little bit dry, so I prefer to think as MCP as a universal language. Like, for example, I'm from Austria, and my most efficient and native language is German. I work with colleagues from all over the world. If I work with a Ukrainian colleague, for example, we are not talking in German or in Ukrainian with each other because that would not work. But we are switching to English because that's our universal language. And it's the most efficient way how we communicate. For us, that bridges the gap instantly. And MCP is exactly this English language for AI, more or less. It's a little bit simplified, but bear with me. It provides essentially a standard way for any AI client, like Cursor, any other IDE, Anti-Gravity, Gemini CLI, doesn't matter, to talk to any tool like GitHub, Slack, or Chrome-devtools via the browser. And they don't need to know each other's native complex internal code or language, right? You just need to speak this MCP dialect or this English language. And once your agent can actually speak that language, suddenly a lot of things change, because now it gains new capabilities, like driving the browser, inspecting the browser, and so on. Essentially gives them additional senses. Okay. For example, inspecting the browser. So far, so good. So how does the MCP server actually work? So that's a little bit of a deep dive on what's actually all of the driving that. So if MCP is the English language that allows us to collaborate efficiently, we have a small problem, right? The browser, Chrome, in that case, doesn't really speak that. Because the browser speaks a very specific, very technical, very complex language called CDP, which is short for chrome-devtools protocol. It's like very heavy, very technical, but also incredibly powerful, right? Yeah, the problem is generalist AI coding agents have a very hard time talking it correctly at scale. So that's where our MCP server comes in. Think of this npm package like a specialized translator. It sits between your AI agent and the browser, and the agent asks for example something in MCP. So agent would be up here, talking with the chrome-devtools MCP server, and This package then translates those MCP commands into something that the browser understands, which would be CDP in that example. And because we have that translator, the agent doesn't need to struggle with understanding browser internals and stuff like that, because our MCP server takes care of that. What it allows the agent is to have a fluent conversation with the browser and also back and forth and stuff like that. So let's break down the architecture a little bit. You see here, so as I mentioned, this is kind of like the bridge, and it's a local MCP server, which is very different from most MCP servers that we might know, because most of them are remote. Essentially, the wrapper around the service, and that service is being called. This is a local one. What this means is it's running locally on a machine. It's connect typically locally to a Chrome browser on a machine. You can also let it connect to any other Chrome browser running anywhere in the network. But that's an advanced setup for another time. But you can also do that. In the green field or in the green package, you see Puppeteer. So that is one part, one half of this package in here. And Puppeteer is being used to provide the fundamental capabilities of this MCP server, like browser activation, clicking, form filling, opening a page, changing tabs, stuff like that. All those things that you already know from Puppeteer, right? Browser activation. Doing screenshots, device emulation, stuff like that. On the right side, there is, in the blue box, there's chrome-devtools. That's also in there. So the chrome-devtools front end, that's the stuff that you know if you do right mouse click, inspect in Chrome. That's being opened. Parts of that, at least the business logic, is also running in that as a separate NPM. So it's a separate NPM package that we extracted. And what it gives us for the MCP server is debugging capabilities, access to console errors, source map support, networking, stuff like that. All those more advanced capabilities that typically they don't have with simple browser activation libraries. So, in short, we're using already existing mechanisms to provide the chrome-devtools MCP server. And why is this useful? Because that also makes sure that suddenly you don't end up in interesting situations where you have to maintain two packages that are maybe doing the same thing, because eventually they will also start to shift, to drift into different directions. It's just going to be a nightmare, because imagine, for example, you're using chrome-devtools and you see some error in there, and then you tell the AI agent, hey, have a look at it. But the AI agent uses chrome-devtools MCP server. It's like, no, there's no error there. You are hallucinating. No, that's not, that shouldn't happen, right? That's why it makes sense to reuse those packages there to make sure that actually information is the same thing. So let's put it to another test here. With a classic developer nightmare is the wrong word. Classic developer task, right? Imagine you get a bug report with a reproduction information. The registration form doesn't work on this particular URL. Sorry. I'm, of course, using localhost here because that's where we are running test applications. Fix it. Thank you very much. Yeah, so what we are not doing here, we only tell the AI agent, hey, it's broken, but we're not telling it why it's broken or what is broken, right? Simply, it's not working. And normally, that's also where the conversation very often stops. Maybe the AI agent, depends a little bit, is going to... I've seen those. I have seen those. I have worked on stuff like that. I have also reported stuff like that. I'm also guilty of it. Typically what an AI agent is going to do depends a little bit. Some of them are going to start a web fetch to that particular URL, and then they are scraping essentially what comes back. And then we'll start fixing right away. Some of them are going to say, hey, can you please give me a browser screenshot and explain a little bit to me what you mean with this not working? Whatever. Long story short, yeah, it's probably not going to be that successful, or it's going to suck because you now need to provide information. But now, as I mentioned, we now have the MCP server hooked up, and that enables it to actually inspect the browser. So it can go in, reproduce it itself, and then also work on a fix. Like, does this work? Yes. Right. So what's happening here? That's another test application. I have a lot of test applications because it makes it easier for presentations to show what's important. It's a form. It's not an Angular form. I think it's in Vue. Yeah. Yes, but it's not. It's not working. It's not working. It's not working. Right. So it's not working. As you can see, there's this mouse cursor down there, and it's feverishly trying to click on it, but nothing is happening. So, okay. So that's what it means. So what happens now next is you will see again AI coding agent. This one, yes, it's again Cloud Code. So it doesn't really matter which AI client we are using, right? Because we're just an MCP server and we don't really care who is talking with us. So that's why we'll see in the demos that I'm presenting all different AI coding agents being used, because we also do that on purpose, because we also are testing on different ones. So it's not an endorsement, it's simply we're using different ones. Okay, but going back to that example, what's happening here, as you can see, there's this prompt, the registration form doesn't work, fix it. It thinks about that and it's like, okay, you know what, I'm going to open the page in the browser and have a look myself. That's what it's doing. It's now about blank. Going in, opening the page, navigating to it, and then it's already starting to take a snapshot of the page and start listing console errors, and it will start to fill the form, do the interaction, right, and try it out, and click on it, and then it would see, wait, something is not working here. It's not going, fixing. Now it's fixing. And, yes, it's fixing it, and then it starts to validate the fix. So it goes again in, reloads it, and then fills the form and clicks on it. It's like, okay, registration successful. Yeah, and that is enabled because it actually now can inspect the browser. And here's also a nice summary that Cloud Code, for example, produces for you as a user, which is also very nice, I think. Yeah. So far, so good. Let's see. I talked a little bit about screenshotting and also about take snapshot, but let's talk a little bit about how an AI agent actually see the page, right? Let's take a deeper look into that. We provide two main mechanisms. There are a little bit more than that, but those are the two main mechanisms. One of them is take snapshot. And that returns an accessibility tree, more or less. So the talk we had today about accessibility was super interesting, actually. What it gives an agent is a semantic understanding about the page structure, and also it tells it which element on the page is actually also being selected in Chrome DevTools. Like if you select one in the elements tree, for example, it will know about that. No, it's not in that one. But then typically it will know that this thing is selected, and it can also reference that. Super interesting. Right. And then, of course, there's also take screenshot. And that returns a screenshot, of course. I mean, that's kind of obvious. It's a screenshot of the whole page, but also a screenshot of an element. Why is this important? Visual comparison, right? If you're saying, hey, this looks off, and it's kind of like he doesn't see that here, but with a screenshot, more capable models will be able to understand what you probably mean. You can also let the screenshot be saved to file. Also depends on the model. Some of them actually prefer it as a file because screenshots in particular, if they get transported over via base 64, have the tendency to blow through your context window very fast. But that's also something for another time. Right. Visual bugs are super hard to fix, right? In particular for text-based LLMs. For example, here, fixed news being cut off in the headers on a Pixel device, and the app runs on localhost. So what is happening here? We now see here two abilities being combined. One of them is emulate devices, Pixel device, right? And also there's like kind of like it looks off, so it will also try to take screenshots, and in order to correct the styling of the page or the code of the page. Right. Yes, this is also Cloud Code. Right, left side, AI agent again, right side, here already Chrome is open, also works. can also connect to existing and already running Chrome instance, and we can configure it all whatever we want. Right, so prompt is being entered, fix news being cut off in the header, nav, on the header nav, sorry, you're going to see what is actually meant by that. It opens the page. That's again the DevTools time, that's our publisher example web page. And now it's going to do a resize page, so it's pixel device, viewport is going to set that to the right size. And what you already can see, right? So it's resizing the page here. You already can see this circle, news is being cut off. Okay. So now analyzing all of that, taking screenshots, searching through the source code, trying out the fix, navigating again to the web page, taking a screenshot, validating that the fix that it created actually was effectful and created the right outcome. Yeah, and as we can see also now it's working. Yeah, in that case, it also gives you a nice summary. Perfect, the fix is working. News and politics now displays completely on a pixel device. It's no longer cut off. The navigation is now left aligned on mobile screens while remaining centered on large screens. Thank you very much. Let's move on. And as I mentioned before, the AI agent can also contextually debug. So if you say, for example, I have selected an element in Chrome DevTools, center it. Yeah, it can also do that. What you see here is the browser is already open, and here, this is a real nice toy example. This is just to show this feature. So, and there you see Chrome DevTools being opened, so you can also debug the web page and then let the AI agent take over and help you a little bit and so on. Right, so as you see, in the elements panel, hello world, this div is being selected. And here's Gemini CLI is being used. I've selected an element in Chrome DevTools. Oh my, this was fast. Center it. So what's happening here? Unsurprisingly, it calls into the browser and takes a snapshot. It calls into the browser, takes a snapshot, and this is another feature that we have. So you can also connect to your already running Chrome instance. This is relatively new. This is like 2 or 3 days old. So top requested feature, like I have this. How can I give access to the current tab to my AI coding agent? Now you can do that with that feature. Right. So that's what's happening here. And allow. And now it's working, and I will center the selected element. It does an evaluate script, so it can also run arbitrary JavaScript, inject that there, and then run it there. For example, it's centering now the web page that you have in there. Right. Okay. I also talked with Julian about that, I think, about that case. And if you have ever opened the Chrome DevTools Issues tab or the console, I don't know. Who in here knows about the Chrome DevTools Issues tab? Oh yeah, it's like 5%. I didn't expect more, to be honest. I didn't expect more. But for the few people that have looked at it, you might have noticed that there's a lot of pages that have a lot of issues, right? There's like deprecations warnings there, there's slow web pages or stuff that you should be doing because they're going to be obsolete. Issues that you should be fixing on a web page. And you can use the Chrome DevTools MCP server to actually let your AI agents start fixing those issues. Like for example, yeah, see this deprecation warning. You know what? Swap it out with something that's actually more current, so the deprecation warning goes away. Like for example, fix issues reported with Chrome DevTools and example.org. Right. This is also a good toy example, of course, because you might have already guessed that, because that this page has issues. Yes, this page has issues. And for the few people, I know it's only a handful here, that have never seen the issues panel in Chrome DevTools. There's a panel for that. It's called issues. So might be a good homework. open it. It's you might be blown away by the amount of issues on some pages. Whatever. What is important here? There's like a few issues here. Like for example, typically deprecation warnings. So deprecation warnings, very often the web platform changes, and because change is constant, right? And sometimes we have to change existing features or deprecate them, right? But we can't do that on a whim right away, right? It needs a little bit of more time, so that's why we issue deprecation warnings on the console or on the issues tab here in DevTools and through other channels to warn developers in advance, hey, this will become a problem in 3 milestones and stuff like that. If you fix it now, the problem will be gone for you and you will not need to think about that. So that's about what this is about. Right, so, but issues, there's like 5 of them. And we told, let's see which coding agent is being used. Ah, yeah, Gemini. Fix issues reported when chrome-devtools on localhost 3000. What happens there? It never gets to the page. That was fast, sorry. It never gets to the page. Gets the console messages, and the console messages, the issues can also be part of that if you want to do that. There's like a filter for that. Ah, yeah, it's here. Issue deprecated feature was used, and then it works through those issues iteratively to start fixing them, but then also to validate that it actually works. Like here again, this console message, no issue. The only thing that's in here is like some log message from the framework being used. And it also gives you, in that case, a nice overview of what issues were actually fixed and what happened there. But let's also visually validate that. If you know, here you have the Chrome DevTools issues tab again, no issues detected. Yay, that's exactly what we want to have. So that's, there should be a happy face here. That would be nice. Okay. And that was just a toy example, right? But that also works on real enterprise environment. So here, for example, we recently published a case study together with CyberAgent, that's a leading IT company in Japan. And I was also laughing internally heavily when I've seen this with their Yahoo email address, because Yahoo is super big in Japan. Super interesting. Whatever, but they face this problem that they have this design system that they have, and they have a lot of issues there, but they never really had the time to actually fix them. So what they did, they hooked up one AI agent, I don't know, either it was Gemini or Claude, I can't recall, to chrome-devtools MCP server, and essentially told it, you know what? Look at all those pages at the design system and start fixing those errors. That's what they did. So they found a handful of errors there and they fixed it, or let it be fixed by AI coding agents. But also afterwards, they had the confidence that, oh, okay, now we actually did this audit and now we actually understand what's happening. Yeah, and if you want to find out more technical details, there's QR code that's directly going to route you to that particular blog post or the case study. Right. The read power, the read power comes when you start chaining MCP servers together, right? So let's look combining 2 different MCP servers. So here you have Gemini CI as the orchestrator, could be anything. Then on the left side you have the Chrome DevTools MCP server that's going to give Gemini CI the capability to inspect the browser. And on the right side you have the Figma MCP server, and as you might have guessed, the Figma MCP server gives the Gemini CI access to Figma designs. Super fun. That is actually an example from one of our UX designers. Consider this. Take a screenshot of the app running on localhost and compare it to its Figma design on that particular URL. Adjust the UI until it actually looks like in the Figma design, right? And that's just an example. Figma is just an example. You can use more good MCP servers to do much more powerful things. Imagine you're doing the same thing with Slack or with GitHub, for example, or Sentry. Super interesting. whatever. Oh. Whoop. Yes, there. How does it actually look like? On the left side, you have Gemini CLI. On the right side, that's just for us, because we want to see what's happening. That's the open Figma design here. But you don't need to open that, because the MCP client doesn't really care what you have for regarding Figma, what you have opened in the browser. And in the middle, you have the web page that they actually are currently developing. There's also chrome-devtools being opened, because why not, of course. Right, so the goal is this thing on the left side, Gemini CLI, should make the thing in the middle look like the thing on the right. That's essentially the goal. And of course it's doing that, right? It opens the page, takes a screenshot to understand what's happening here, how does it look right now. It calls into the Figma MCP server to get the design, and then it starts, you already see, it starts changing source code, and it's like, that doesn't work. Spinning, and it's like, okay, yeah, that looks fine. It's taking a screenshot again, comparing it. And the UI has been updated. You can now see the changes in the local host. And I think they look very good. Nearly, yes. Close enough. Okay. So, we've seen the power of chrome-devtools, both in a single instance debugging, but also multiple MCP servers together. Like, for example, to fix visual regressions or changes. The features that I mentioned here is just a starting point. Essentially, we want to provide even more, of course. So here it's what is on our roadmap right now. And what's coming is cookie management and management for local storage. Because, I mean, kind of makes sense, right? To also have access to that. How you can think about that is we want to give the relevant parts of the application panel, make them available to AI coding agents too. Then the next one is I mentioned cyber agent and also show you the issues, but we want to give coding agents more capability to actually do more powerful audits. So they will also be able to run full lighthouse audits via over MCP. So you can make even more crazy stuff with that, right? And third, right, we want to extend what you actually can debug and inspect with the MCP server. And right now, working with extensions is a little bit complicated. And we want to make that a lot easier, that your AI coding agent is able to inspect, to debug, to work on Chrome extensions too, like they would be with any other web page. And finally, and that is the one I'm very excited about, because source maps. That's the big one. It's like source map support. So what this allows is that your agent now is actually able to debug production websites. Because in production websites, you will have minified codes, and so on. All of that is going to run, which is not a code that the agent actually sees in the IDE, right? But with source maps, they can make this connection, and they can trace back production errors that they are seeing, or production problems that they are seeing, trace them back to the actual source code, which effectively gives your agent extra revision into your production website if you want to have that. So, to summarize, chrome-devtools MCP is the missing link in your development loop if you're using AI coding agents and you're developing web applications, which I guess all of you are doing. It connects your AI agent directly to the Chrome browser, be it a separate instance, be it a running instance, doesn't matter. There's a lot of configurations there also on our website. It hands the agent the power of chrome-devtools, so it can also inspect, debug, and do all that stuff. The interesting piece is that it changes also the workflow, how you're interacting with your coding agents, because up until now, kind of like, oh yeah, make a few changes and then you need to go in and also validate everything yourself. But this is like a little bit unchaining everything, because now the AI coding agent can also reproduce it itself, can check the outcome itself, and you will have a lot more confidence when it comes back, I finished a task, that the task is actually being finished, because now at least it can do all those needful things that typically would expect from a developer to do. With that, then steps into this review phase. And this development loop I mentioned at the beginning, where it's only was spinning writing code, now expands into, in particular, into this review phase and also is able to check the outcomes. And if you want to try it out yourself, that's the QR code you need to go. Or this URL, same thing. But the right one is nicer and also more suitable for your mobile phones. The project is fully open source, as chrome-devtools is anyway. And we're just getting started. So feel free to use it, please use it, but also feel free to contribute, right? We have, today I think we talked with you, right? No. So I talked with somebody who was like, when are you going to make it open source so they can contribute? You can already do that. We already got PRs from people and a lot of issues are being reported there. And yes, we are looking at them and working through them. Like for example, this connect to live browser instance that was like heavily requested by the community, and we got a lot bad words were said to us because we are so slow, but the thing is it actually takes a little bit of time to make it work with a read browser in a way that you don't yeah, you also have to consider privacy and security. Whatever, try it out, try to contribute, give us feedback. We would love to hear from you.